Okay, here are the answers to 3 through 8, and I put next to them the property. I think it's really important here for me to note on number 8. So number 8, there's an if and a then. This is so important. If, let's say we have 3 over 6 equals 1 over 2 equals 5 over 10. If this happens, then 3 plus 1 plus 5 over 6 plus 2 plus 10 equals 3 over 6, which equals 1 over 2. Now, it's not because whenever you have a situation like this, you can't look at this independently. You can't just say that that's true all the time. And let me show you. If I have 3, 6, and I say 2 plus 8, and then I say 7 plus 1, I can't say that this is just 3 over 6. There had to be, for this to work, you'd have to say 3 over 6 equals 2 over 7 equals 8 over 1, which we know is entirely not true. Entirely not true. And that's why this isn't true. You can't just cancel out addends. You can't do that. That does not work. We're not just canceling out 1 over 2, 5 over 10. The whole idea of what makes this property true is that this if part happened first. So go back to those Venn diagrams. If this happens, then you can say adding all the numerators of the proportion over the sum of the denominators of the proportion is equal to the value of that first ratio. Okay, so that's the only time. We're not making up rules with math, so please don't get in your head that you can do this all the time. This is only true with proportions. Okay, I think that concludes the lesson of ratios and proportions. So hopefully you've got enough to go on. Where we're going to use this is with similar polygons, similar triangles. I know you've got some experience with similarity, but now we're going to take these properties of proportions and we're going to apply them in future lessons to similar figures. And similar figures is all about ratios and proportions. So with the practice that you're going to get here, you should be very able to handle the math that's coming.